Hi, my name is Nitesh Sharma and welcome back to Microsoft Azure Developer Implement Azure Functions course. This is third part of the part 1 and we have already discussed Azure App Services, Azure Virtual Machines and we have also discussed containers. And now we are going to discuss Azure Functions. In this course, I will be teaching you the essentials that you need to know about Azure Functions in order to meet the objective of your exam AZ-204. Started. In particular, there are three skills listed under the implement Azure Functions exam objective, and these are implement function triggers by using data operations, timers, and webhooks, implement input and output bindings for functions, and implement durable functions. We will talk about all of them one by one in next slides. Let's continue. In particular, we will tackle each of these skills in next three modules of the course. But to get started, I will explain what Azure Functions are. Introduce some key terminology such as serverless and function app, and I'll show you how to use these Azure on in Azure portal to create an Azure function application. So we will demo on Azure portal as well. Let's start by quickly introducing Azure Functions. Azure Functions is a serverless application platform which provides a simple way to run a small piece of code or functions in the cloud. You might hear it referred to as a function as a service platform. Serverless means that rather than having to provision um, and maintaining server ourselves, we delegate that responsibility to the cloud provider. We simply provide our code, and serverless platforms also support automatic scaling to meet demand and offer billing models where you only pay for your code while it's running. So while you are using it. So Azure Functions are grouped into Azure Functions app, which is a collection of one or more related Azure functions that are developed, deployed, and hosted as a group on that same specific Azure application. So Azure App Service. So let's say in Azure App Service, you had one single Azure App Service plan, and you hosted one or two Azure App Services on that. Here you are all still having the same Azure App Service plan, but you are paying for what you are using, only for what you are using. Let's say your function is being used only once or twice a day. It doesn't make sense to keep it alive all the time, first of all, and then second, you don't need to pay for a whole day then, right? So you can make use of that ability from cloud. We have three things we are going to talk about: programming languages, hosting, and development environment. In this course, we are going to talk about first is programming languages. So you can use Azure Functions offers a lot of choices and flexibility. First, it offers a choice of programming languages. You can create Azure Functions in C#, Java, JavaScript, Python, PowerShell, and many other programming languages are also available. In this course, we will see demos that use JavaScript and C#. I prefer mostly C#, which are which is most commonly used with Microsoft products, commonly used with Azure Functions as well. And then we have second, you have a choice of hosting environment. Azure Functions are usually hosted in service plan or Azure App Service. So there is a consumption plan which is a serverless pricing plan, which bills you only while your functions are running and automatically scales out to meet your demand. This is the most commonly used service plan for hosting Azure Functions. One limitation it does have it is that there is a time limit of 5 minutes for each function invocation. There is also app service plan which doesn't have this time limit and uses a more traditional pricing model where you pay monthly for the compute resources you are reserving, and there is a also a premium plan which offers faster performance, enhanced security options, and reserved instance which are always ready to run your functions, but does also offer serverless automatic scaling capabilities. Alternatively, you can also run Azure Functions in Docker container, and we have already talked about Docker possibilities, and but uh, Docker container allowing you to benefit from the Azure function programming model on premises or in any cloud provider. And you can run Azure functions locally, which is great for development and testing. In this course, I will show you example of running Azure functions in the consumption plan and locally. So let's get started. And then the third one, finally, the Azure Functions gives you choice of development environments. You can develop directly in Azure portal, and this is great for learning and quick experiments. But for most applications, you will either want to use Visual Studio, which is practically a good choice if you are using C# and running on Windows. And you can use alternatively you can use these Azure Functions core tools, which are cross-platform command line tools, and you typically use these in conjunction with other editor like Visual Studio Code. We will see 3 of these development environments in action in this course. Let's so let me show you how to create an Azure Function app in Azure portal. You can do this by clicking create resource in the portal, and I will take you there in a moment. Let's go there. So here I am in my Azure portal, and here you see I created few resources yesterday, but I deleted them, so you don't see them here anymore. I have a subscription called Azure Subscription 1, and it just gives me direct option to create a resource. Here you in the left side of the portal you have you can click on the frequently used things, and function app is one of them, and you can just click on this and start from here, or you can also click on create a resource, which will give you a search option. So you can many ways. I will just click here function app, and it just shows me how many function apps I have, and I don't have any here. I will just click create, and it will take me to the plane where it asks me for a few more details, and here it by default selects my subscription, and then it asks me to get a resource group, which I don't have for moment any. So I will say tech of the day 204, and there is no resource group like this, so it will I will say create new like this, and okay, and it will create this resource group. Then we go ahead and it asks for the function app name. Let me see if it is available. It is available. Tech of the day. If I try to remove it and then test it, yeah, it is also available. So I'm going to create a function app name tech of the day dot azure websites dot net. So as you can see, this is a domain name, and then that means that this name function app name should be unique on Azure websites.net, right? So this is, you can say this is the subdomain and this is the main domain name. So it should be unique on this one. So within Azure websites, this name should be unique. Then if you go further, you have two options, and if you want to deploy via code or with the Docker container. We said if you select a Docker container, it just asks you for the region, and then it asks you for the operating system you have underneath you want. And if you select code, it just asks you for the runtime stack and which version of that runtime stack, and then region. So region is in a region is required for everything, but these two things changes. So runtime stack and version, if you select via code, and if you just change it to Docker, then you need to say only the region. So I'll go with the code, and let's say you have multiple options here for the runtime stack: .NET, Node.js, Python, Java, PowerShell, Core, custom handlers. I'll go with the .NET, and then it asks me to select a version of .NET framework. It has multiple frameworks, and okay, for the function app, there is difference to note here. For the function app, you see only two options available: 3.1, which is Core .NET Core 3.1, and 6 .NET 6. um, but for the function app, for the normal app service, it gives you many more options, like it even gives you a .NET 7 preview now, because while I was doing it yesterday and creating a function app service, it was giving me option for .NET 7 preview. But yeah, it depends on the time of the year. And now we are in end of August 2022, almost September. So the .NET 7 preview is available already. And yeah, so let's continue. I selected .NET 6, Windows, operating system Windows, and it is asking me to select the plan billing. As I discussed, you have three plans now. So consumption plan, which is serverless, function premium, and app service plan. So app service plan is the same like you have for your app services, and it's you can reuse that plan as well, but that is like you are paying for the fixed compute price for 1 month, right? So but the benefit is you can host multiple function apps in this using the same app service plan. Or if you go with the consumption plan, which might be cheaper, because you will be paying only for the consumption you are doing. That means the function app, for the time your function app is active, but it might be expensive if your function app is running 24 hours. So then better option is to use app service plan. Anyway, let's continue with the consumption plan. Then I go with the hosting, and when creating function app, you must create a link or general purpose Azure storage account that supports blob, queue, and table storage, because you need one storage account for the function app here. And then you go with the networking. I don't want any networking here, so I am not using any VNet or anything. But as I'm not allowed as well, is only available in function premium and basic, standard premium, premium v2, premium v3, dedicated app service plans. So because I used used the consumption plan, I don't have this option available. So if I want to use, if I want to integrate virtual networking, VNet integration, then I need to be either on the premium uh, and basic, standard premium, premium v2, premium v3. So either I should be on the premium, or I should be having app service plan, which is basically the requirement for this. Okay, and then I go with the monitoring. I don't want for now actually to have any application insights, but if I want, I can simply have application insights. That means my anything, any problem, error, logs, everything will be logged into application insights. I think I would do that, because the benefit is if I want to debug my Azure function, it will log everything here. One thing I want to change here is the region, because by default it's selected Central US, but I want to do it in the North Europe. I will change it in a while. So region I want is North Europe, because my subscription plan is basic and it doesn't allow multiple regions. So but that is only to me, and now my function app is almost ready. What happened just now is it just validated my selections, and now if I click create, it will create, and now I already have the arm template. I have been repeating this during the last videos as well. While you are on the portal, and when you are trying to create a resource, by this step you already have the template here. So if you want to download this arm template and then use it for your code integration, so if you don't want to do it manually via portal, and for the next time you want to keep it in your repository, so source code, then you, if you want to deploy or create Azure function app using CI/CD pipelines, you can do that as well, and that is arm template. You can download it here. So I will just go ahead and create it, and now the function app is being created. Now I already have the function app, not yet. And what happens is I just created a deployment. I want you to pay attention here. You created a deployment. So deployment means multiple resources might be created, right? Because I selected many things. I asked to create a resource group. I asked to create a storage account. I asked to create also for log analytics. So you see a lot of things are created. You see Microsoft inside. So log analytics is created, and then you have storage account, you have server forms, you have another storage account. So you see multiple things are being created here. If you want to pay attention, and now we want to go to our resource. So go to resource. The deployment is completed, and now we are in our Azure function app. For now, this function app might not be having anything. You see your function app 4.0 app is up and running, and that's it. You see nice. Oh yeah, okay. A nice, but anyway, this is up and running, and you see if I go back here, I don't have any functions in here. If I go here, you see I have no function. So I have just created a function app for now, and if I want to add functions, so I just want you to differentiate. I just created a function app, and now I need to create a function in it, because I might have multiple functions, right? So let's create a function. This time I'm going to create a function via using the portal itself, development portal. You can also have VS Code. You can have other tool like PowerShell or Azure CLI. For now, I'm going to do it in the portal, and then I'm going to select a trigger. What type of trigger I want to use. I will explain in a while what are the triggers, what are these things. For now, I'll just select HTTP trigger, and then I'll just say create. So it is going to create a Azure function based on HTTP trigger. Okay. Okay. Now I have it, and it just gives me option to code and create test my Azure function. And you see, I have this code. This is the code I have, and yeah, simply connected. You are now viewing logs of function runs in the current code plus test panel. To see all the logs of this function, please go to monitor from the function app menu. So if I go to monitor here, and I can in the real time I can also debug the problems I might have or requests I'm receiving here. Anyway, we'll talk about it later. So first of all, I just want to just change a little bit in the code itself, and I just want to test it. So response message is this, but I also want to add here uh, tup, 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 request, and now in here I want to return something. Let's say This is HTTP trigger function executed successfully. uh, and I will say, and it was added for testing AZ-204. Let's save and test. So this is actually a simple post request to this method, and I'll just say I'm sending name Azure and run, and I should receive a response now. 200 output is hello Azure, this is uh, this HTTP trigger function executed successfully. Oh yeah. Okay, and here uh, here you see other logs. um okay, anyway, let's continue, and I hope you understand this was just a basic explanation about function app, and you have many other things. I will talk about them in a while. These are almost like app service things you have, um, and you should know them by now. But yeah, I hope it is clear. Let's continue. Implementing function triggers. Introducing triggers. Okay. Hi, my name is Nitish Sharma here, and in this module, we are going to learn about how to implement function triggers. Triggers are what causes an Azure function to be executed, in simple words, right? As just shown you in the exam, in the portal, how to create an Azure function, and while I was creating in the portal, you had a lot of Azure function triggers which were there, and we wanted to see them here. So if you see them here, you see you have few of them are here. There are many more triggers you might have. So in this module, we will look at three examples of triggers. We will create an HTTP request trigger function, which is how you implement webhooks. We will create a scheduled task, which uses a time trigger, and we will use a blob storage trigger, which is an example of basic data operation. And we will implement all of these in the Azure portal using the function app that we created in the previous module. So let's continue. um, every Azure function has exactly one trigger. The trigger is event that causes the function to run, because as you know, the concept of function app is serverless function app. That means it is not running continuously, but it is running on a trigger. Okay, so Azure Functions support many types of triggers, and we only have time to see a few of them in action in the course. But let me tell you about some of the most commonly used Azure Function triggers. An HTTP request trigger allows us to create an Azure function that runs in response to a web request. This allows us to implement webhooks or to create RESTful APIs using Azure Functions. So it is similar to REST is APIs, because it will execute when you call this endpoint, let's say. So basically, it's similar like REST APIs. A queue trigger, sorry, I forgot. A time trigger allows us to create scheduled tasks such as function that needs to run at midnight every night. A queue trigger allows us to run a function in response to a message on a queue, which could be Azure Storage Queue or Azure Service Bus Queue. A Cosmos DB trigger allows us to run a function in response to a new document being created or updated in the Cosmos DB database. A blob trigger allows us to run a function in response to a new file being uploaded into Azure Blob storage, and there are many other triggers types, including event grid or Microsoft Graph. Actually, you can create triggers on many resources, which are, so basically, if there is any change on any resource, Azure resource, you might create a trigger. This is to explore actually. So And HTTP request triggers are one of the most commonly used triggers types, as they are useful for implementing APIs and responding to webhooks for external systems. When you use an HTTP request trigger, Azure Function lets you customize which HTTP methods such as GET or POST and can be used to call your function. You can also customize the route to control the URL of your function, and HTTP triggers can be secured by requiring an authorization key. There are three authorization levels. Anonymous level means your function doesn't require a key, or function level requires callers to provide a key that's specific to just that function, and the admin level requires a key that can be used for all the functions in the function app. Let's create a function that uses HTTP request trigger. Here we are. So I will go back to the Azure portal, and I will explain you how to create I have already done that. Actually, I have already created HTTP based trigger, and but there was no authorization level on the function, which means that the call to that function um, doesn't need any authorization code. So I will do something with the authorization as well. I will change the authorization, and we will try to call that endpoint and see if it reacts. Okay, let's continue. Let's go to the demo. Okay, we are back in the Azure portal, and as you saw in the previous demo, we created a function app, which is tech of the day. And if I just go to this app directly, I can just go like this, and the app was running up and running. And then we created a function which is called HTTP trigger 1, and I just deployed it, and I just created the first function, but I did not show you many other things like authentication, keys, and everything. We are going to talk about that in this demo now. So you see here, I'm in this function we created, HTTP trigger 1. I did not rename it or did anything with it. I just created it, and then what you can do, you can still change its name, of course. If you go to code and test, you can do a lot of things with it. You see here, you are passing a request, HTTP request, and a logger, iLogger will be used for logging, log analytics, and every error, status of the application, everything about the application into log analytics, which we can later on check. And then this request is containing the user input, which we can use, send some information to it, and then that thing can be used in the program itself, in your function app itself, and then it does something with that, and you can use that. So that's a simple app here. If I go to further things like what is the definition of this function, what are other settings. So you see here, auth level is function level, which means at function level you have the authentication level. You might have anonymous, or you might have function level. Then the name of the request is request, then type is HTTP trigger, direction in method get or post method, and then the response is type of HTTP as well. So that's it about and then you have readme, and then it just talks about yeah, something about the function. Pay attention to it. It might looks a bit different what you have in your Visual Studio Code, because, or in your portal, because I selected here .NET 6, which .NET 6 gives you a lot of flexibility, and writing the syntax is a little bit different. So you might have different styling of different syntax of your code, but nevertheless, don't worry about it. Let's continue. Then I want to and then okay, then you have function key at the function level. So this is I'm specifically inside the function, and then I have the function keys inside the function level, and then I can get the keys. It is so slow. I just hate it. I don't know why. Anyway, it's here, and I should have. So you have one function key which you can hide and use it. And then you go here, sorry, in the overview, and if you want to check, get the URL, get the function URL, copy it, and I just go to this part and you see it. So you see here this function, HTTP trigger function executed successfully, pass a name in the query string or in the request body for a personalized response. And I passed this code. So I used because here you see we saw the default key, which is function level key, and then that key is passed in the request itself with this code, and I used it and it is successful. And if I remove it, then I get 401. You see error, HTTP error 401. That means that it doesn't work because the authentication doesn't work, because it needs a code to access this function app, sorry, this function. And then it says if you pass a variable called name, which is simply tech of the day, and I will pass and then you see it is working, hello tech of the day. That means because in the code here you see I'm using the name passed in the query that is being used here, so it will display the name. So basically that's what it is doing here. So basically yeah, that's it about the creating the HTTP triggered function app. I hope you understood and enjoyed it. Let's continue. We are again with the triggers. So now recently we talked about HTTP trigger. Now we want to talk about time trigger. Time triggers are a simple but powerful way to run scheduled tasks in the cloud. When you use a time trigger, you provide a cron expression that determines when your code function should execute. So I'm gonna create a time trigger and see how it is going to execute, and then we will see it will actually it should execute on its own, and then we'll see what it does. Let's go to the Azure portal. Okay, so after HTTP triggered function, we want to create time trigger function. And when I click create function, deploy develop in Azure portal, and you see here you have a lot of options, many triggers. Then the second most important and most used is time trigger, actually, which you see here, time trigger. And I selected this and I say create, and it is going to create a time trigger function for me. And you see it just created a time trigger function named time trigger 1. And if I go to code plus test, and if I see the code, it just have this time trigger my timer ilog as input, and it just does this part. So it just displays what it is doing. If I see the function.json, which is actually the bindings for this function, and you see the name my timer, which is it is sending, type time trigger, and then direction is it's an input, and then schedule is cron expression. If I go to this chrome expression, this means that it's every 5 minutes. So basically this we have created a time trigger for 5 minutes, but I will change it to 1 minute to just see it in action. And we go to monitor here, so that to see if it is actually working. And you see it the last one it executed was um, 25 of August 11:34. But yeah, I'm expecting another run here. So basically, it should execute again. I will pause the video and wait for 1 minute. So when we are seeing this live, in monitors tab, you have option to invocations, and you can also look into logs. When you go to logs part, you are connected to the monitor part of the application, and you are actually seeing the live logging here. And this is really good for debugging any problem. And you see it is active for 2 hours, and I would highly recommend you to use this when you are developing your function app. Yeah, so it is supposed to be running every minute, as we changed the logging part, the cron example. So we changed it, and you see it is triggered within 1 minute, and it says executing function, time trigger one, time fired at this, and C# timer executed at this. You see, so basically it will trigger every minute. If I continue looking at it, it will keep doing the same thing. It will keep publishing this. So that means, like, what I have done here is actually working. Okay, so um, you see here. Okay, right. And then if you go to uh, overview and try to get the function URL, you don't have it because it's a time triggered. It's not a webhook. You cannot call this function yourself. It will be triggered automatically, and that is the main advantage or disadvantage sometimes. So yeah, let's see. Let's continue. I hope it is clear. Another important trigger is blob trigger. As an example of data-driven trigger, we are going to trigger a function where whenever a new blob is uploaded into blob storage. Once again, when I click to add the function and create the blob trigger, this is the third most important or third most used trigger. So I will just go to once again. I will just go to the portal and I will explain it to you. See you there. Okay, again we are on our Azure portal, and we are in the function of tech of the day, and in the function part, I'm just gonna click create function, and same way I'm gonna select a trigger. So here you have multiple triggers: Azure Queue Storage trigger, Azure Service Bus Queue trigger, Azure Service Bus Topic trigger, Azure Blob Storage trigger, Azure Event Hub trigger. We want to add Azure Blob Storage trigger, and that means it will trigger when when on a specific storage account and a blob is added. So let's go to the function itself, and let's see what it created by default, because we just clicked and added it. So by default it might have things. So you see stream blob, which it is, that means it is sending the blob to it, name of the blob, and then logs. And if I go to function.json, and I see here I have input as my blob trigger direction is in, and then you see it is pointing towards sample work items slash name. So if I just go to another tab here, Okay, so as you see, we created blob trigger 1, and this was actually here in the test trigger container, which is I uploaded a demos.txt file using upload here, and this is a container within this container within this storage account. And if you go here, you see when I uploaded demo.txt, it detected the blob and it triggered the function app. So basically, if I go back to this code and test, what was happening, what we created, actually it was, if we go to function, it was checking for the past test trigger, and slash dash name is, this is the name of the file. So basically it is waiting for this, and then if I just go here, it triggers with the stream itself. So I have the blob, and if I want to do something with the blob, I can still do something. I mean, I have whole information about blob as a stream, so I can use that, and the name is the parameter we passed from there, which we displayed in the, if I go to monitor, and you will see here it was triggered 2 times. And if we check the last one, this one, you see executed the blob and details were this. So it was triggered by the blob change, right? So you have all the information here. Function processed blob name demo.txt size blah blah blah, because it knows the information about the blob. So I hope it is clear that we can create blob trigger, HTTP trigger, and time trigger on the Azure portal. You can change their names. If I just go here and I want to change its name, I can change it, and I can do it other way. I hope it is clear. With that, let's continue. Uh, let's continue. Hi, it's Nitish Sharma here again, and in this module, we will learn how to implement input and output bindings for an Azure function. We will learn about the various types of input bindings, which simplify the process of getting data into our function from external systems, and we will look at output bindings, which allows us to do things like sending a message to a queue or adding a new document to the database. We will be using Azure Functions core tool in this module, demonstrate the process of developing Azure Functions locally. A binding is a connection actually to the data within your function. Binding are optional and can be input or output. Input bindings are used when we want to read access. Read access to the data from the external service within our function, and output bindings are used when we want to write data to the external service. So a function can have multiple input and output bindings. Some examples of available input bindings are blob storage binding, which can read the contents of a blob. When you upload a blob, when you have blob trigger, you have the possibility to read the blob stream, as I shown you in the previous example. And same way also you can have from Cosmos DB binding, which can look up a document in the Cosmos DB database. And several other input bindings are available, such as Microsoft Graph, which you could use to read a document from the OneDrive. For example, Azure Functions also provide many output bindings. Example include Azure Blob Storage, which would allow you to create a new file in the Blob storage. Azure Key Storage, which allows you to post a message to a queue, and Cosmos DB, which allows you to create a new document in the Cosmos DB database. And there are many other, including Event Hub, Service Bus, and even connectors to third-party services like SendGrid for sending emails, to Trello for sending text messages. Yeah, many more. So you have many more third-party as well. Let's continue. Let's do the demo. In this demo, I'm going to create HTTP request trigger uh, using JavaScript function and use a Cosmos DB input binding to read a document from Cosmos DB. Let me quickly tell you the tools I have got installed. The Azure Function core tools, which are cross-platform command line tools for working with Azure Functions app locally, Visual Studio Code, which I'm using as my code editor, and I have got the Azure Functions Visual Studio Code extension installed, which will simplify creating the bindings. I have also got the Azure Storage Emulator and Azure Cosmos DB emulator installed locally, which means I don't need to create a storage account and a Cosmos DB database in the cloud. To create a new Azure function project, you just use the function init command in a new folder, and this project is going to use JavaScript. So I will select node, then JavaScript, and I will open this folder in Visual Studio Code, and then I will start. So let's do the real demo. Okay, we are here in my Visual Studio Code, as I told you, and I have a Node.js function app, which is simply getting the context, request, and input document. And input document is a type of, if I go to, I can check what type of input document is. And in the bindings here, you see it's a list, and in the list itself, you see the bindings like auth level is function level, type is HTTP trigger, direction in, and name is request. So if you connect them with the function itself, you see here request, and here it's the type. It's so the input parameter here is request, which is type of HTTP trigger, and it's an input, and method used are get and post. Then you have type of output direction, which is output binding, and you simply saying it's an HTTP output binding, and this is the response. So if you go back to the function itself, and here in the context dot response, you are saying body dot document dot desk whatever, but you are sending a changing the response here, and which is by default will be responded back. If I go back here, and then we see the type of Cosmos DB, it's an input document, and database name demo, collection name to do, connection string Cosmos DB connection, and then ID is query ID, and this. So basically you are putting an input type of input document which with this query, and to connect it with this local Cosmos DB. For clarity purpose, I have this Azure Storage Explorer, which by default gives me possibility to create an emulator. I have a storage account emulator, and I also have Cosmos DB emulator, so I can just use this. And I also have data lake storage generation 1 preview. This is with old version, and you see here I have Cosmos DB, and which is running on localhost. So I don't really have to create a Cosmos DB in my Azure portal to test it. Simply I can supply the connection to this Cosmos DB, and this will work. Next to it, we have queue, which is a type of queue, and direction is output queue item, and it's a web job storage. Let's go to index.js, what it is doing actually. So if you see here, I'm checking if the document input document, if it's not null, then let to do item run query ID blah blah blah, which is a request. In the request itself, you have this value, and then context.response, you send the response with 404 and the message, and you set the output by queue item with this message. So you see context.bindings.output queue item. If you go back here in the function, and if you see output queue item here, which is being set, so basically we are setting back the context.bindings, and then you have this parameter output queue item, and you are setting this with this message, basically which we need to send because it's an output binding. So I hope it is clear for you to understand input bindings and output bindings, which it is very important to understand. And then I can go here, and you see I have added the Cosmos DB connection, Azure Web Job Storage, function worker, and I added the local connection string like this, what I have in my data in my Azure Explorer, which is a local Cosmos DB, kind of a fake DB, you can say, not real in Azure. And but it doesn't matter, right? It's kind of an actual DB, Cosmos DB. And then in the host settings, you see here in the host settings, it's not really doing anything different. Just setting the extension function bundle, this one, and then yeah, not really much doing here. Local setting and packages, no, not really anything special. And yeah, that's it. So I hope it is clear. To run this message, I just have to do function.start and it will execute. To do that, I can just go here and run function.start, function start, and then it will execute it and wait for any context document in the Cosmos DB uploaded here, and respond accordingly. So if I add any document to this, and then to this database, I need to create a database, the one which we are looking for, and then I can upload a document. So basically that's it. I hope it is clear to you how the input and output bindings works. You just need to understand that it's a simple way of input and output fields actually to a function, which we have in general in C# or any other language as well. As parameters are the inputs and the outputs are the output we send back to the caller of that function. And same thing is happening here. So basically the caller of the function is someone from the internet, and that is sending a request, and request is actually input to our function, and the output is same response. So we change the context, HTTP context. Basically that's it. So I hope it is clear. Let's continue. Nitesh Sharma here again, and in this module let's learn how to implement Azure Durable Functions. Azure Durable Function is an extension to Azure Functions that enable you to create stateful serverless workflows. These workflows are referred to as orchestrations by durable functions. Let's continue. So the programming model consists of three types of functions. First is client or a starter function. This is an Azure function that indicates a new orchestration. It can use on any of the Azure function triggers we have already looked at. Second is orchestrator function. This is the function that defines the steps in the workflow and what order they are performed in. The orchestrator function can also handle errors that happen at any point in the workflow. However, the orchestrator function doesn't perform any of the actual steps in the workflow. That's the responsibility of activity function. We will explain that in a while. An orchestration consists of multiple activities that can be performed in sequence or in parallel activity functions. And activity functions can use any of the input or output bindings we have looked at earlier in this course. And orchestrator function do have to adhere to some quite rigid guidelines. And at the moment, it's recommended that you create your durable functions either in C# or JavaScript. For this demo, in this module, I'm going to use Visual Studio Code, Visual Studio, and C#. Let's continue. You have orchestration pattern. Let's review some of the orchestration pattern that durable functions make possible. Function chaining is where we want to execute a sequence of activities and functions in a specified order. The orchestrator function keeps track of where we are in the sequence. So let's say we first execute activity 1 on Azure function, then we go to the next activity, then the orchestrator, and then activity 3. So in whole flow from here till here, the orchestrator function will keep track of these activities. This is simple chaining. And then we go to next one, which is fan out. It is a pattern that runs multiple activity functions in parallel and then waits for all the activities to finish. The results of the parallel executions can be aggregated and used to compute the final results. And this pattern is very hard to achieve without the use of a framework like durable functions. So basically, you start your activity 1 and then you do activity 2, which is a parallel execution of multiple functions, and then in the end you wait for all of them to execute here, and then once they execute you go to the next activity. The next pattern, asynchronous HTTP APIs. This pattern is useful when you have an API that you need to repeatedly pull for progress. You start off a long running orchestration, and then your orchestrator function can manage the pulling until the operation has completed or timed out. So you start a process and then you do the work, then you wait for it, and then you need to get the status continuously from this. So you keep getting the status and you keep waiting. So basically it's asynchronous execution, because here this do work is doing a lot of magic work. So you need to get the status of it. Next is monitor. The monitor pattern implements a recurring process in a workflow, possibly looking for a change in state. You could use this pattern to repeatedly call an activity function that's checking to see if certain conditions are met. So you have a work in progress, and you keep checking if something is changed, and for that you just poll and sleep and you keep checking. So it's kind of a monitoring for a specific thing. And then you have human interaction. Human interaction, it's very common in business, very common workflow which require manual approval, where the workflow must pause until a human has interacted in some way. This pattern allows workflows to wait for certain events to be raised and then optionally perform mitigating actions if there is any timeout waiting for human interaction. So you you make a request approval to human interaction, and this human comes in, and if he approves it over the time or not within a time frame, and then you continue with the process approval, and if there is anything, he can or she can escalate the matter. Then let's create a durable um, functions workflow using Visual Studio. I will start by creating new Azure C# function, and I will select the function app project type and call it durable function app. Let's go to Visual Studio Code. Okay, I have created a function app in my local Visual Studio, which has these two things: function one and my orchestration.cs. In function one, I have a function uh, which is called function one, and the authorization is at function level, and the inputs are request only, and then in the request I can get the name. It's the same function which we created in the beginning, and it's HTTP trigger. And then second is my orchestration. So my orchestration function, which is we just talked about, so which is the type of durable icon orchestration trigger. So this is a type of durable function, and inside this, so we have output, and then in the output I have added three activities which are simply calling three functions in parallel. So you see it is calling say hello, and these are calling in asynchronous. It is important to see you are adding a wait call activity async, and you are adding these three activities. So we called activity named my orchestration hello, this one, and then second one my orchestration hello, again the same activity, and third activity with the same, and then we return the output to this. So and then you see here I'm just passing some very values Tokyo, Seattle, London, because this activity accepts an input which is string type. I could pass an object or anything. Later on, this is simple function app. Later on, you could also add a dependency injection where um, you don't have to pass things like this, but you will have a proper dependency injection with the startup class, which is a bit more in detail and deep with Azure Functions. So it can be same as you have normal apps, REST APIs in your in C Sharp with the dependency injections. Here you don't see that here yet, but you could achieve that. But that's a bit more in detail. I would like to do that in a separate video, not in the context of this certification. So let's continue here. Here you and then you see so this is hello, and there is another one which is my orchestration http start, and it can be with the authorization level anonymous, and with the durable function starter. Okay, so then it is just printing the instance id here and check status response. So let's go ahead and execute this function. So build this, and it will build it, and yeah, run it. So that there are a few errors, and no error, gone now. um, let's, because it is, oh, okay. So you see here we have launched our function app, and you have function one, which is simply calling the API, this one, and you have other my orchestrations. You have orchestration trigger and activity trigger. These two can be triggered with the orchestration. So below, this app is up and running and working. For your learning purpose, I would suggest you to go through it and look for it. You could also find latest examples in Azure samples. I would suggest you to do that, because this might be a bit old by the time you watch this video. I would suggest you to do yeah, your own research and do it yourself. It's nothing difficult. Um, it's not really that difficult. I think just get started. I would just ask you to get started. I hope you liked it, and let's continue. Nitesh Sharma here, and in this module you will learn about custom handlers. By now you should already know that you can create Azure functions in several different languages, including C Sharp, Java, JavaScript, Python, PowerShell, and many more. But what if you would like to create Azure functions using languages that's not currently supported, such as Rust or Go? So, or maybe you would like to use a runtime that isn't currently supported, such as Deno, which is an alternative JavaScript runtime. And this is where custom handlers comes in. Custom handler allow you to implement Azure function using your language or runtime of your choice. And of course, for the majority of situations, it still makes sense to build Azure functions using one of the built-in languages. So quite possibly You won't ever need to use custom handlers, but it is worth being aware that this option is available to you for those scenarios in which you do have a need to make use of different languages or runtime. In this diagram, we can see an overview of how custom handlers work. Just like with regular Azure functions, a trigger such as HTTP request or a message appearing on a queue is what causes the function to execute. And it's the Azure Functions host that receives this trigger along with any associated payload data. However, to execute your custom handler, it makes an ongoing HTTP request to web server that's running your custom handler code. Any data associated with the trigger or input bindings of your function is passed on to the custom handler via the request payload, and the custom handler can also return data to the function host in the response payload. If your function has an output binding, the function's host can use the response data from your custom handler and pass it on to the binding target. And this means that so long as your language of choice support running a basic web server to receive the requests from the function host, you can implement a custom handler in that language. So here you were triggered, if a call was triggered via any of the trigger, and then your function internally it calls a custom handler, and then with its request payload it returns a response, and then it prepares the output bindings. So same way, it's kind of in between. Let's continue. So let's discuss the main steps involved in creating custom handler. First, we need to create a new Azure Function app, which I recommend to do using the Azure Functions core tool with the funcs init command inside an empty folder. And when it prompts you for which language you want to use, you need to select custom. And this will add a section called custom handler in your host.json file. The second, you need to create an Azure function again. Again, the tooling can do this for you, and you can choose whatever trigger and type you like. For example, you might choose a HTTP trigger, and this will create a function.json file defining the triggers and bindings for your functions. And this is exactly the same as already you have regular functions. Third, you need to create the executable that implements the web server in your language of choice, and the official Azure Functions documentation helpfully provides a quick start example which shows you how you can do this in both other languages like Go or Rust. And because that's executable, which we don't want to talk about because that's what it can be, whatever, and all. And then you have which has handler or something, and yeah, that's it. Pretty straightforward. And in the function app. And finally, you should also be aware of the purpose of the extension bundles. These are needed to support the bindings and triggers that you use. And this in this section, which is host.js, JSON file defines the extension bundles that are available and gets auto-generated for you when you create your function app. So like this, you could get started with your creating the custom handler. Right, that's a wrap. Please write down your comments, questions, and suggestions in the comment box, and good luck with your exam. I hope you learned something, and because I tried to explain everything in my own way, maybe I wasn't clear enough, and maybe you have some feedback for me. So I would really appreciate your feedback. I put a lot of hard work in it, but maybe still it is not enough. I put more than 100 hours in preparing this course because it's really long and uh, it covers a lot of topics. Still, I might not have done a lot of demos maybe, but I would be creating a separate video for that, which will cover labs and some some other exam topics. So thank you for watching and enjoy tech of the day. Enjoy this course and good luck for your exam. Hope it helped you a little bit, at least some degree. Thank you. Have a nice day or evening, whatever is suitable to you. Thank you. Bye. Have a nice day.